where the bond is going to break easily and where it is going to be broken with difficulty. Justin, can you hear me? Yogita? This is left hand side, you have directly benzene. Oxygen has lone pair. And what will happen between the lone pair and the benzene ring? Then resonance. Is it clear? Got it? So this bond, this side, will have a partial double bond character. It will have a partial double bond character. It will not break so easily. So we are going to break it in this manner because there you have a resonance. So H and I. Is it clear or not? So what all products are we going to get? We are going to get this product and this product, right? Not this one. Not this one because this requires breaking of phenyl and oxygen bond that will not break because it is partially double bond in the characters, right? Jasleen, I hope you understood the answer. A and D.
Yes.
Okay. Very important. This will be SN1 cleavage because this cation can form very easily. Okay. This cation is resonance stabilized, so it can come out, but that side, the left hand side, can't break easily because that has partial double bond. Okay. So a bit difficult question. But still, if you have that just now whatever I told, that thing in mind, you can easily make out that the only two options fulfill the criteria for the correct answer. Only two options. And then from the two options, you can shortlist the correct one. I hope you can see the question. So what should be the right answer? First, you should look at the oxygen directly connected to benzene. And you should not separate that oxygen which is directly connected to benzene because that will have a partial double bond character and that double bond is very difficult to break. Getting my point? So if I follow that point, I will have two options correct. A and D. I'm not going to just in this I'm not going to break. Look. This bond will be partially double bond. Okay, because of the resonance. Right. And I should not break this bond under any circumstances. This should remain intact. This oxygen should go with the benzene always. Is it clear? Because under normal conditions, it will not be broken. And if by looking at this point, we can shortlist two options. We will further shortlist the final answer. So what are those two options which can be shortlisted by knowing this, that phenyl and oxygen bond is not going to separate very easily because of the resonance. So this will be there, A, right, OH, and this is there. Okay. This I'm not going to choose, this I'm not going to choose, right? Clear?
Yes, sir.
Okay. Now we will proceed to the above part of the molecule, that is also ether. And this oxygen can break very easily because this cation is resonance stabilized. Got it? This cation being resonance stabilized, it can form very easily. So this can let the oxygen go away. Because this oxygen is not like the lower one, which is directly linked to the benzene and which is in resonance, involved in the resonance and the double bond character with the benzene. This oxygen is separated. There is a carbon in between. That carbon can do resonance if it has positive charge. So the carbon will let the oxygen go away. And if that has positive because of the resonance, got it? So I minus will get connected to the positive part. Okay. So we are going to have that option D as the final answer. Is it clear or not? Any doubts on this? Very good question. Two types of ethers, right? Jovita, any doubt you can ask me, right?
Yes, sir.
I hope it is clear to you. Okay, Justine?
Yes, sir.
Okay. This also the same thing. Same cleavage of ethers. I'm asking cleavage of ether because you can expect some questions. Okay, these are the most common part of the questions, okay, which are there being asked in NEET. So again, I'm not going to break the bond between the oxygen and the benzene, which is directly linked to oxygen. And based on that, I select two options. Okay, this one and this one. This O will not get separated from the benzene because it is in resonance. If it is in a resonance, it has a partial double bond character. And if it is a partial double bond character, it is difficult for us to break it and separate it. So we are going to keep this O, and what will happen to the CH3 group? That I will get connected. That will come out as CH3. Okay. And what will happen to this? This part you have a cation because of the benzene ring, and the cation will have the iodine, just like the above molecule, above example. Same as that of above example. Okay. But so the structure is little bit changed, right? So this you can leave because that is from the advanced, so no need to do that. Okay, that's one. So this is the same question. Let me take the other NEET questions. I mix some questions of NEET and J together so that you can have a clear idea of what sort of questions you can expect. Okay. So let me write some other question. on the alcohol ether chapter only. There are many questions I can see from the acidic basic strength, right? Many questions related to phenol, tests for primary alcohols, secondary alcohols, and tertiary alcohols. And you have cleavage of ether, but that question is very simple, direct question. In ether in 2017, you had this question in NEET, and this was very simple question. And just now I told you, whether you take HI 1 mole, 2 mole, or 5 mole, or any moles, you are not going to break this bond because of the resonance. So what will be the answer? Okay, and the options, they have given various options, but I will not discuss that because we have already discussed much better question than this one. Got it? So you will have CS3I. Okay, so this question was asked in NEET, but that already we have discussed, so I will not be discussing it again. Next question. Very simple question. So they have asked, this is NEET PYQ, they have asked this reaction can be classified as alcohol formation. Absolutely not. First option is clear, that is not alcohol formation. Got it? Dehydration. It is Williamson ether synthesis. Or cleavage of ether. So what it is basically?
So what kind of reaction?
Which one?
So you're asking what kind of reaction?
Dehydration. Which
Is it
which one?
Williamson's?
Yes, it is Williamson synthesis. Exactly. It is formation. It is not dehydration. Okay. This is sodium hydride. Okay. H minus and Na plus. And sodium hydride is a strong base. Okay. So what it will do? It will extract the H plus. So X is basically O minus Na plus. The H plus is removed and H plus is replaced by Na plus. Got it? So, and H2 will also be liberated, but normally we don't concentrate on the inorganic product. Once you have this O minus, it will react with CH3 ion it will do the SN2 reaction, okay, on CH3 ion, and you will have OCH3, methoxycyclopentane, okay, being formed on as a final ether. So it is a Williamson ether synthesis, right? Obviously, it's not cleavage of ether that uses HI. Dehydration uses concentrated H2SO. Okay. So this is from the NEET. NEET questions are very simple for chemistry, and just you should score 100%. Okay, they are very simple, but be alert that you don't make a mistake. Next question. This is bit tricky question, slightly tricky. Okay, from 2013, bit old also, but bit tricky. Related to ethers only. So among the following, which ether will produce methyl alcohol? Upon treatment with hot concentrated HI. This is good question. So, Justin, you need to know the mechanism, right? So, which mechanism basically it is following, whether it is SN1 or SN2, right? That you need to figure out to get the correct answer. Yeah, with hot concentrated HI. Will produce CH3OH. Means the oxygen is going to go with the CH3. Normally, these reactions are SN2. The I minus attacks on the smaller alkyl group CH3 because it is SN2. So if that is SN2, if the reaction is SN2, you can never get CH3OH. I hope you are getting my point. Because if it is SN2, you will end up with CH3 ion, not with CH3OH. Because I minus will attack, okay? And that's why the mechanism will be SN2. But this is asking something very different. CH3OH, what it means? CH3OH means the cation is going to form on the tertiary carbon, right? Means the cleavage has occurred from the tertiary carbon. Okay. So that can happen if the mechanism is SN1, and mechanism will be SN1 if you have a stable cation. And stable cation, for stable cation you need either a tertiary group, okay, or a resonance stabilized cation. So among these, only one cation is very stable, carbocation, and that will form by removing the oxygen, and that is this cation. This is tertiary. So once you have the H plus protonating this oxygen will break apart. Cation will be left, and cation will get connected to ions. Got it? So in this case only, you are going to get CH3OH and tertiary butyl iodide as answer. Is it clear, Jasleen? So very good question from your NEET PYQ only. Okay. So just be careful about it. In all the other cases, you have both primary groups. Okay, both sides. So primary group SN1 cannot happen. SN2 can happen. And if SN2 can happen, that will happen on the CH3. CH3I, CH3I, CH3I. You cannot have CH3OH. That can form only in the option C. Because there you have a tertiary group. Got it? So I hope this is clear. Basic question, but very important question. Next. So what is Z? Structure of Z. So what should be the right answer? Be careful in counting the number of carbon atoms. There, that is where it can go wrong. So this is also from NEET PYQ. Be careful in counting the number of carbon atoms. So what should be the answer? Jaslin, just try it and let me know. First reaction is anti-carbonic of addition of HBr in the presence of peroxide. That you can easily do. So Br is going to come on the outer carbon because it is anti-carbonic of addition. And then that outer carbon Br will be replaced by ethoxy group. So you will have ethoxy group. So you have ethoxy group. That is common in all the four options, right? Just you need to check where this Br is. So it is anti-carbonic of addition means H will not attach to the carbon, atom bearing more hydrogen. Instead, it will get attached in a reverse manner. It will get attached to the carbon atom bearing less hydrogen, H, and Br will attach to the carbon atom bearing more. Yes, option A, exactly. Right? So, but you need to count this as CH3, okay? So normally what happens that, okay, there are four carbon, normally we take it this option, there are four CH2, 4, okay, CH2, this total there are 5 carbon, that is not the answer, okay? So option A is correct, right? So these things you need to keep in mind while solving this problem, okay? Next is the major product you need to identify. Very simple. You need to know the mechanism. So just as you can see here that there is no tertiary group which can form a stable cation or no resonance stabilized group which can form a cation. So SN2 reaction will occur, and if it is SN2, because this is primary, this is 0 degree basically, and this is secondary. So both will not form a cation. Tertiary can form a cation easily. So I minus is going to come and attack on this. Right? It will be SN2. Okay. So if it is SN2 CH3I, and you will have this. Okay, B as the correct option. In your test notebook, I've checked that you need to go through the Grignard, okay, and the reduction. So this question appeared in NEET regarding the NaBH4, right? And I am asking this structure, but I will add from my side, I will add some extra thing, okay? Part of it was there in the NEET and part of it I am adding. So you can directly tell me what has happened with NaBH4 C2H5OH. And also let me know, actually they have given various options. And there are two places where the reduction can happen, right? Either on this ketone or this is the ester, right? Be careful. And uh, let me write some extra point which is not given in the NEET question. This is PYQ, the structure. There were four structure. The question was only this much here with NABS4. But this is from NEET 2021. But from my side, I am adding LAH also, LILH4 also. So that will complete our discussion. Okay, LiLH4 is a strong reducing agent, you know that. And it can react with aldehyde, ketones, and all the carboxylic acid derivatives get reduced by LiLH4. All will give alcohol except the amide, which will give amine with LAH. Okay, NaBH4 can reduce only aldehyde ketones and only RCOCl, mainly aldehyde ketones. No carboxylic acid, no ester, no anhydride, right? No amide. NaBH4 is a weak, and LH is a strong reducer. Is it clear?
Yes, sir.
So this is very important. Okay, so now we can start knowing the structures. Structures were given in the options, so which I have not written here because I have from my side I have added this LH part. So NaBH4 is a mild reducing agent, and it is going to reduce only ketone. Ketone, yes, and ester, no. So I'm going to make this ketone as OH. leaving behind the ester untouched. This is the answer which you need to choose from the given options. Okay. The lower part was not given in NEET, which we are adding from our side. This is strong reducing agent. So it is going to reduce both the aldehyde ketone as well as carboxylic acid, ester, right? All, right? Carboxylic acid. So I will reduce the ketone and make it OH. While I'm also going to reduce this ester. So look at it very carefully. This will get cleaved. This double bond will change to OH. Keep track of the number of carbon atom. There are 2 carbon atom outside the ring. CH2, CH2, OH. And this will change to OH. And that will come out as CH3OH. Okay, that will also break. Both part will become alcohol. Is it clear? Okay, this is the reduction with LiLH4. Right? Jaslina, I hope it is clear to you.
Yes, sir.
Okay. The same part. The first top part is the ester and the lower part is the ketone. You have the carbon on both the sides. And likewise, you have similar questions in your NCERT in text also. So that's why it is very important. And that's why they have also given. So I'm going to reduce this ketone, leaving the ester untouched with NaBH4. But with LiLH4, I'm going to break this ester also and make both the portions as alcohols. So you have it as an alcohol, this as an alcohol, and this also as an alcohol. Got it? Clear?
Yes, sir.
Okay. Now, Grignard. Let's talk about the Grignard. So this is also from a recent NEET 2021. They have given acetone, reacted it with C2H5 MgBr in the presence of ether, which is the solvent, to mix the Grignard. Followed by acidification and hydrolysis. The product, and they have asked the IUPAC name of the product. So just do it quickly. By the meantime, I will write the options. 2-methyl butane to all. So what should be the right answer? Acetone is there, that is propane to all. This is from the recent NEET 2021. So the problem is simple, but actually they have also added IUPAC nomenclature, which can create more troubles because of the lack of time. Yeah, Justine. What should be the answer?
Sir, is it 2-methyl
Option
to option D?
option D. 2-methyl butane to all. Because this is acetone, right? This is acetone. And when you try to add, so this is minus and plus. Okay, oxygen is more electronegative. And when you try to add the Grignard to it, so just attach this minus over here. Got it? And once you have that MG, make it OH. Got it? And now for the IUPAC naming, we need to choose the longest chain. Giving lowest number to the carbon atom bearing OH. So this is 2-methyl propane to all. Right? Let's
Yes,
do
sir.
one more question. So this is IUPAC name they can club, but mostly they keep the question simple, but normally the problem can happen due to lack of time or because of the examination pressure. Okay, this is related to the catalytic hydrogenation reaction. This is little bit knowledge is required. H2 gas they have taken, and the pressure which they have taken is 1 atmosphere. Means they have taken a catalyst. Catalytic hydrogenation reaction, palladium carbon. One atmosphere pressure is just the pressure in which we are currently present, that is 1 atmosphere. It's not very high. Okay. So options they have given. So this is basically about the reduction. Option D is not going to be the answer. Because you can't have an intermediate as the final product. Got it. So either you are going to choose option A if both the double bonds are completely reduced, or B or C. So, but this is from your NEET PYQ only. Okay, be careful. C should be the answer. Okay, because this is basically less reactive than the alkene, so that will undergo. Do remember it. Okay, that will be the answer, right? Because this is thermodynamically more stable, more stronger bond. And if you have more stronger bond, surely that will not break.